Um, okay. Hello, everyone. Hello once again. Question 11 is the next one we'll be looking at. But I just realized that the song that was playing in the background in the previous video was not good. I don't like that song. I don't like those collections of songs, really. I prefer love songs, and I don't know about you. So I'm not trying to make you like the kind of songs that I like, but if you're watching my video, then you need to listen to the love songs as well. So there we go, love songs. Songs from the 80s, I guess. A circle with center C has equations given as x squared. It's a circle, remember, so circle equations are very common in A levels. You should by now be used to them. So the equation here is x squared plus y squared plus 8x minus 12y equals 12. And you're told to find the center and the radius. So the question is, what do we do? So the first thing you should realize is that this is not how we like to write circle equations. Who did this? And the moment you figure that out, you say, oh, now I see what we're to do. So we prefer to write it like this. This is the way we prefer to have circle equations. If this is written in this form, then we can simply say that the center has coordinates a, b, and the radius is just equal to r. But unfortunately, it hasn't been written in that form, so that means they want us to write it in this form, so we can tell them what the center coordinates are and the radius. So shall we therefore do it? And at this juncture, what you would figure out is that this is simply a question of completing the squares. Now, if you feel you're not too confident about completing the squares, maybe you should just listen to what I'm going to do. But if that doesn't help, I have a full video on the trick you need to use in completing the squares. It's a very straightforward trick. I only wish you'd have time to go through it. It's one of the videos, if you just scroll through, you'd see it. Or you could just Google or YouTube search anybody's video on completing the squares. It's very useful. So I have x squared plus 8x. I have y squared minus 12y. And I have 12 on that side. But I want to write it as x plus something squared plus y minus something squared equals something. How do I know that this has to be minus and that has to be plus? Because unfortunately for us, this is no longer a minus, it's now a plus 8x. So that symbol there goes there. This one is already a minus, so that's what it takes. You can't give what you don't have, right? So if that's minus, then this has to be minus. If that's plus, this has to be plus. Now the trick about completing the square, not the actual trick that I was going to talk about in the other video, but the trick here is that if that's 8, half of 8 is what goes there. And if that's 12, half of 12 is what goes there, 6. Right? But if you look at, and of course we have our 12 still there. 12 is still patiently waiting. I like 12, it's so patient. What have we then introduced into this equation? If I expand this, you'll see that we're almost still where we were, but we've added something else. I'll take a rough sheet now and try to show you what I mean. So we had x squared plus 8x, and I have given you x plus 4 all squared to replace that. How different are they? If you expand x plus 4 all squared, what you would actually get, if you take your time to do it, you're going to get x squared plus 8x plus 16. But what we had was just x squared plus 8x. So what right do I have to replace x squared plus 8x with x plus 4 all squared when that has brought in a new stranger, which is plus 16? It's okay. Whatever is good for the goose is good for the gander. That's a proverb, okay? So whatever is good for the goose is good for the gander. So if we are going to introduce a plus 16 on the left hand side, we have to introduce it on the right hand side as well. So we're also going to introduce that stranger on the right hand side, because we know that by doing this we have introduced something else into what we were meant to have. If you look at this one, what have we introduced? So we had y squared minus 12y, and I've told you to replace it with y minus 6 all squared. But does y minus 6 all squared actually expand to give you y squared minus 12y? I don't think it does. Who does? No one thinks so. If you expand this, you're going to have y squared minus 12y plus 36. Now take your time to expand it using the FOIL method. You remember the FOIL method? F first, outer, inner, last. So by the time you do all that, first, outer, inner, last, you will see this is the solution to that. But this is not what we wanted it to be. Who brought in this stranger and why? So what right do I have to bring in a 36, which was not given, right? So by introducing a 36 to the left hand side, I must do it to the right hand side. So I have to introduce a 36 there as well, because I know that I've done the same here. So if you add this up, you have 12 plus 16, which is 28, plus 30 plus 60, sorry, plus 36, which is 64. So I have this now as x plus 4 all squared, y minus 6 all squared, plus 64. Now 64 is just 8 squared. So if you compare this to what I was talking about here, if you compare this to that, you can see that we can say the radius is therefore 8. But what can we say about the center C? What's the coordinate of the center? If it had been x minus something, that something would have been the x coordinate. But it's not x minus 4, is it? It's x plus 4. So where's that something? Well, x plus 4 is x minus minus 4. So x minus minus 4 means that this other minus 4 is the x coordinate. And for y minus 6, thank God we already just have the minus there already. So 6 alone is the y coordinate. Yeah, Titanic. Nice song. I like this song. It's an old song. People listen to it during Valentine, but I don't care. I listen to it every day. Alright, so that was question 11A. 11B tries to make it more interesting by saying the points P and Q lie on the circle. The origin is the midpoint of the chord PQ. Show that PQ has length n root 3 where n is an integer. And this is a question for how many marks? I reckon 4 marks. 5 marks. We have to be extremely careful here, don't you think? The points P and Q lie on the circle. Fine, no problem. We know a lot of things about the circle now. We know the center of the circle. We know the radius of the circle. We know the equation of the circle. So we're not scared to deal with points P and Q. It says the origin is the midpoint of the chord P and Q. So we have the circle. We have the origin. This is the origin, 0, 0. The origin is not necessarily the center of the circle, okay? But this origin is the midpoint of those two guys, P and Q. So if this is P and that's Q, then the origin is right in the middle of those two. Ignore my drawing. Sorry, I think I wasn't showing you everything. Ignore my drawing, okay? The point P and Q, this is the origin. This is the origin now. The point P and Q could just be 2 points like this, P and Q, where the origin is right in the middle of whatever connects them. And the center of the circle is still there. So it doesn't really matter how I draw it. What matters is the picture you get from it. You can see that we have lines like that. Okay. What do you think about that? All right, ignore what I've drawn. Let's solve this question. Enough of the playtime. The origin is the midpoint of the curve PQ. Show that the PQ has length n√3. So what do you think we should do? What's your thoughts on this? Do we have any ideas from anyone in the building? Or have you all gone hiding? Anyone? I think you should take a minute to think about it. Take a minute to think about it. You'd never know, you just might work it out yourself. So tired. I'm waiting. Does anyone have any idea? Do you think it's something that you can do in an exam, or would you skip the question? It would be nice to know what you would do. You could leave your answer in the comment section below if you have the time. Alright, it's not a difficult question, okay? It's not a difficult question. Alright, let's do it. The point P and Q lie on the circle, so they would satisfy the equation that we have. And the origin is the midpoint. If the origin is the midpoint, that tells you something. You know, when you have x1 comma x2, when you have x1 comma x2, when you have x1 y1 and x2 y2, what we usually say is that the midpoint is the point where you have the average of their x values and the average of their y values. So for that midpoint to become the origin, that means the average of the x values gave 0 and the average of the y value gave 0. And that's just telling you that x1 and x2 happen to be same in magnitude but opposite signs. So like plus something minus something, like plus 5 minus 5 kind of thing, plus 7 minus 7 kind of thing. So if you take the average, you definitely get 0. So that's to tell you that P and Q have similar coordinates, but just one is the negative of the other. So that's an idea we can get from it. And if we have that idea, can we go ahead to guess what the solution would be? If both of them happen to be solutions in the, point on the circle, then we can use the equation of the circle now, which says x minus x plus 4 all squared plus y, where do I have the equation written? Where have I put it? Okay, x plus 4 all squared plus y minus 6 all squared equals 8 squared. And now we know that there are 2 points, P and Q, that lie there, and the origin is the midpoint. But to show that the length between them is n√3. Okay. If I have just said to you that it happens to be that if one of the coordinates for the x is something like, let's say 2, negative 2, the other one has to be 2. And if the other one is, let's say, negative 3, then the other one has to be 3. So you have points like that, and they lie in the circle. You have the center of the circle there. The origin is the midpoint of these two. Like that. I hope that was it. Okay, that's not a very good circle. But when you have something like that, we can now make this into a shape. Like that, a triangle. We cannot tell the distance between these two, but we can tell the distance between their midpoint and the center of the circle. So the midpoint here is 0, 0. The circle's center is negative 4, 6. We can tell the distance from C to the origin, right? And I just told you earlier that because we have these two appearing as opposite sides of themselves, that's an isosceles triangle, and you're now meant to find that length. What's going to be this length? this one I've just shaded, is that the radius of the circle? Yes, it is. So let me just take 1/2. Well, I'm going to take everything now. That's what we have. This is P, this is Q, this is 0, 0, and that is -4,6, and this is the radius of the circle, and that's 90 degrees. Okay, you're told to find the distance PQ. Pythagoras theorem if we know the hypotenuse and if we know the vertical height. So let's call the vertical height H. Okay, so I know that PQ would have to be, using Pythagoras theorem, just this length, P to 0, P to O, I'll call it PO, would be square root of R squared minus H squared, and therefore PQ will be twice of PO, which is twice of the square root of R squared minus H squared. I know my radius is 8, so that is 2 root 64 minus H squared. The only question now is, what is my H? To know H, we just need the distance between 2 points in the XY plane, and that is another trick you need to know for graphs. The distance between 2 points x1, y1 to x2, y2 is usually just Pythagoras theorem when you find the distance between them. So x2 minus x1 squared, y2 minus y1 squared, and then you take the square root. That should give you the distance between 2 points. Okay, the difference between their x's, the difference between their y's, of course, squared of each. That's just Pythagoras theorem. So in this case, the distance between O and 0, 0 and -4, 6 is 0, take away -4, and then you square that. That's 0 minus 4 all squared, plus 0, take away 6, and then you square that. So if I square my -4, it's 16, and if I square 6, it's 36. So 16 plus 36 gives me 54. No, 16 plus 36, beg your pardon, gives me 52. So square root of 52, right? So H is actually square root of 52. So H squared is just 52. So this now means square root of 64 minus 52. And 64 minus 52 is 12. So this is square root of 12. So PQ is 2 root 12. Okay, so PQ is 2 root 12, which is 2 root 4 root 3, and that is 2 times 2 root 3. So the answer is 4 root 3. 4 root 3. Now I have a feeling that I have not explained this very well. I'm sure you must be like, wait, that was too fast. What was he doing? So let me try to explain this slowly this time around. Okay, so we have a circle. The center is given as -4, 6, and somewhere along the circle we have the origin standing there, 0, 0, and we've been told that this origin is midpoint between 2 points that lie on the circle. One is called P, one is called Q. So by experience you would know that as long as this is at Q, the distance to the center must be the radius R, which we have said before is 8. And that's the same distance here, 8. Now this is looking like a hypotenuse, like an isosceles triangle, right? Now if O is halfway between these two, then I can just stop there and say, well, it's halfway, so okay, we don't need to stop there. Let's go all the way. But it's halfway, so right in the middle is this straight line that goes to the top of the triangle. And with an isosceles triangle, if you draw a line from the middle of the isosceles to the top, to the crest, you would always get that to be 90 degrees. It's always going to be 90 degrees. You can take that to the bank, okay? So this becomes a Pythagoras problem. Let's call this point here O. It's the origin, but let's call it O. So the distance PQ is the same thing as twice the distance PO. And the distance PO is just, if you're going to look for distance PO, let's call this H. Distance PO is just by using Pythagoras theorem. It says square root of the h squared minus h squared. But the question is, what is h? H is just the distance between the origin and a point -4,6. And usually to find the distance between 2 points, we would usually just do the difference between their x values, we square that. The difference between their y values, we square it. So the difference between the x value of 0,0 and -4,6 is 4. And you square that. The difference between the y value from 0,0 and 6 is 6. So you square that. And that gives you square root of 52. So h is square root of 52. That means h squared is 52. So if h squared is 52, put that there. This is 64, take away 52, and that gives 12. So square root of 12, 2 times root 12, right? So that's 2 times root 12, and that gives you 4 times root 3. Okay, if you still have questions, like I told you, hit me up on Skype and I will get you enlightened. Definitely. I'm always happy to answer questions, okay? You can always keep your questions coming. Question 12 now is an interesting question, okay? Question 12. A sculpture formed from a prism is fixed on a horizontal platform as shown in the diagram. The shape of the cross-section of the sculpture can be modeled by the equation x squared plus 2xy plus 2y squared equals 10. X and y are in meters. X and y represent the horizontal and vertical. Find the maximum vertical height above the platform of the sculpture. Right, this question is a very interesting one because if you've not practiced past papers before, trust me, you will be confused. It's 8 marks, right? Because it's 8 marks, it tells you that it's something you really want to listen to. Now, I don't know why this is the song I'm listening to. I feel like listening to Ed Sheeran or James Arthur. Should we just try James Arthur if you don't mind? I think James is more passionate about the song. Well, you can put your comments in the section. You can put your comments in the section about what you think about James Arthur and Ed Sheeran. I think James Arthur is more passionate about the things he's singing about. Alright, back to maths. You know music goes with maths, right? So yeah. So we have been told that there is this oblong or ellipse prism sitting on a table, and we've been told that the model was drawn out of a function x squared plus 2xy. Okay, it's not a function, but it's just a relationship. Sorry, I wasn't showing you anything. Okay, so that's the equation that models this. Usually this is the x-axis and that's the y-axis, but mind you, they've been very careful about this. They actually did not put the origin at the bottom. The origin is there, so this is how it goes. That's what I said. If you've not solved questions like this before, you might be lost. So usually the origin is somewhere halfway. So if that's the peak, y max, and this is the trough, y mean, then the vertical distance will be y max minus y mean. You know, it's like when you have a graph like this, and this point is +5 and this point is -5. Definitely this height has to be 10. 5 minus -5, okay? So the vertical height above the plate, above the surface, is going to be y maximum minus y minimum. So it's not just going to be twice of y maximum. Well, it could be if you get the same value for the maximum and minimum. Why not? So let us solve for the maximum values of y and the minimum point as well. So if you have x squared plus 2xy plus 2y squared equals 0, what you want to really do is to find dy dx. And when you find your dy dx, to get the maximum and minimum point, you equate your dy dx to 0. So it's okay, it's what we do every day, isn't it? But how do you find dy dx of a mixed problem like this? It's called implicit differentiation. It's called implicit because we cannot separate x and y. We have them tangled up and we are going to handle it like that. So we can break it into what they are. I can differentiate that easily. I can differentiate that easily, and I can use product rule to do this one. If I differentiate x squared, I would usually just get 2x. If I differentiate this one, of course it's just 0. If I differentiate 2y squared, normally differentiating that should give us 4y, but because it is not supposed to be differentiated with respect to y, we're going to have to be, we're going to put our guilt conscience there by putting dy dx beside it to say, I'm so sorry, I didn't mean to differentiate you, I thought you were an x. And so it's going to be 4y, but with a dy dx written beside it. Now let's try to use product rule for this guy, shall we? We have 2x and we have y. Product rule says that, let me just remind you of what product rule says. It says if you have a function uv, then dy dx is going to be u dv plus v du. So differentiate one of them at a time. So I'm going to leave my y and I'm going to differentiate my 2x. So I'm going to leave y and differentiate 2x. When I differentiate 2x, I get 2. Good. Plus, I'm going to leave my 2x and I'm going to differentiate y. Now, I shouldn't be differentiating y because it's with respect to x. But if you differentiate y, usually we'll get 1 as the answer. But we are guilty because we shouldn't be differentiating with respect to y. So we're going to put our guilt conscience there beside it, dy dx. To say that I'm so sorry for differentiating y, I know it shouldn't have been, so here's my token of apology or whatever. So let's rewrite this. Now we have 2x plus 2y plus 2x dy dx plus 4y dy dx equals 0. We want to make dy dx the subject, so can I factorize dy dx here? It's common to them, so take it out. So that's 2x plus 2y plus dy dx into 2x plus 4y equals 0. Take these guys to the other side and divide both sides by 2x plus 2y. I know I've jumped that step. I don't feel like breaking it down. Oh, you need to understand. I need to drink water. All right, that's better. I'm losing my voice now, so I don't know how far I can go with the rest of the questions before I break the video. So if I just make dy dx the subject, it becomes negative of 2x plus 2y all divided by 2x plus 4y. And if you factor out 2 from the top and from the bottom, it becomes minus into x plus y over x plus 2y. And that's your dy dx. We've solved the dy dx by implicit differentiation, okay? So if dy dx is now set to be negative of x plus y over x plus 2y, what happens when dy dx is 0? What do you think about x and y relationship when it has to be equal to 0? So we'd simply say if negative x plus y over x plus 2y must be equal to 0, then it means that the numerator must be 0, because if a over b is 0, b cannot be 0. A has to be the 0 guy. Okay, so if minus x plus y is 0, that means x plus y is 0, and that means x equals negative y. Okay, or you can say y equals negative x, whichever. Now this is not the end. we're taking this back into our problem, into the equation and the question, to see what, if x is negative y, can we now solve for either of them? Okay, so if we can say dy dx equals 0 and we end up with a solution that says x is negative y rather than x equals 4, which we are always used to, usually trying to find minimum and maximum point should tell us x equals 2, x equals minus 3, something like that. But this is telling us x equals minus y. So no problem, we're going to take this back into the question and drop it in the equation and see whether it helps us with the real answer, with the proper answer. So going forward, this becomes, if x equals negative y, and we already have x squared plus 2xy plus 2y squared equals 0 as the equation, and someone is telling us that x equals negative y, that means I can replace my x with negative y. Wherever I see x, I can put negative y there. So negative y all squared is y squared plus, okay, that's now going to be a minus 2y squared, and that's a 2y squared equals 0. So at the end of the day, what do we have? We have y squared. Wait, there must have been a mistake somewhere. Have I made a mistake? And have you been quiet about it? Dy dx gave us well, I don't think I've made any mistakes, to be honest. So why am I having if x equals minus y, throwing that back in the question. Ah, look, I made a mistake. It's my fault. It's my fault. The question did not say equal to 0. I'm sure you must have been wondering, what's he doing? The question says 10 on this side, and of course that doesn't change anything here because we were differentiating, and because we were differentiating, derivative of 10 is still 0, so that has not affected it. But that's going to be useful in the replacement thing that we are trying to do. So this is equal to 10, not 0, right? It's equal to 10, and so that's 10 there, that's 10. So this cancels this, y squared equals 10, y is therefore square root of 10, plus or minus square root of 10. If y has to be plus or minus root 10, then that tells you that the maximum and the minimum point would happen when y is positive root 10 and when y is negative root 10. So remember, the height is just going to be the difference between the two. So positive root 10 minus negative root 10, and that's just double of root 10. So that's 2 root 10, and that's the maximum, and it's in meters, by the way. And that's the height, vertical height of this. Right, I need to give a quick recap of what we did, just so that you're not confused. We had this oblong shape, and we were told this one, and we were told that it's modeled according to the equation x squared plus 2xy plus 2y squared equals 10. Sorry, that's 10 again, and I apologize for that. I really apologize. I do apologize for that. The maximum point and the minimum point will be somewhere up and down because the origin is usually somewhere in the middle. Okay, the origin is not at the bottom. Now we need to find the stationary points, which is what tells us the maximum and the minimum. So the stationary point is only got when you have dy dx equals 0. So first you need to get dy dx out of this equation. And this is a mixed problem. You have x and y all tangled up. So you can only differentiate this when you use implicit differentiation. Implicit means that we will differentiate the x and we will differentiate the y with our guilt apology left behind. And that means that when you differentiate a y, pretending like it's an x, you'd have to put dy dx after it. So we went on to differentiate each of them. We could differentiate x squared as 2x. We could differentiate 2y squared as 4y, but because we were not meant to differentiate a y, we would now put our guilt conscience, which is dy dx, behind it. If you differentiate 10, you get 0. To differentiate 2xy, that's product rule, because we have a product of 2x and y. So in product rule, which says that you differentiate one and leave the other one, plus leave the other one and differentiate one, whatever I meant. So we're going to leave y and differentiate 2x. We're going to leave 2x and differentiate y at different times. So I did that by leaving y and I differentiated 2x to give me 2. Then I left my 2x and I differentiated y to give 1. But because I shouldn't be differentiating a y, I'd have to put my guilt conscience, which is dy dx. And now we have this full equation, and we can rearrange and keep rearranging till you have dy dx equals all that. Now if that's your dy dx and it must be equal to 0, then how else can dy dx be equal to 0 other than saying that the numerator must be the 0 guy? Alright, and so we said that if the numerator must be 0 for that to give you a fraction that gives 0, then it means that x is negative y. So we took that x equals negative y back into the question and threw it there to solve for y, and that's how we solved y equals root 10. Okie dokie, no problems at all. Question, what question is this? 13. Prove the identity cot squared. Now when it comes to identities, I don't want you to panic, okay? Your formula sheet has got a whole lot for you. How many marks is this question, by the way? 3 marks, just 3 marks, so you shouldn't panic at all. Proof is question 13. It says, prove the identity that this is equal to that. I do not even think you need a formula sheet for this. It looks like one of those ones you can just break and make. So it says cot squared theta minus cos squared theta. It wants us to prove that this becomes cot squared, cos squared. Usually you need to break it to make it. So break it to make it, break it to make it. I'm going to break my cot into what I know it to be, which is cos over sine. But because it's squared, so it's the squared of each of them, minus cos squared, okay? Theta. Now this is a fraction over 1, obviously, and when you're trying to solve things like this, you'd want to have an LCM of sine squared. So there you have your cos squared theta, and here you'd have cos squared sine squared. So that's cos squared theta sine squared theta, because we've simply multiplied the top and bottom by sine squared just to make it have the same denominator. Now cos squared is common to the top, so we can factor it out. So if cos squared theta goes out, what do you have in the bracket? You have 1 minus sine squared theta, and at the denominator you have your sine squared theta waiting. Because I know what they want me to get, I'll just do it the way they want it. 1 minus sine squared is cos squared, and you would remember that from the identity that we say all the time, which is cos squared plus sine squared should be 1. So if you take your sine squared there, you have cos squared to be 1 minus sine squared, right? So 1 minus sine squared is just cos squared. So that becomes cos squared theta, another cos squared theta over sine squared theta. Obviously, this would give you cot squared theta, and there you still have your cos squared theta. And that's what they wanted you to prove, and it's 3 marks. I think most times when it comes to things like identities, learn to break and make. Break it to their sine, cos and whatever, and then you see how you can rearrange to get to what they want you to have. Question 14. I'll do this in the next video. I think you must be really bored right now and you just want to go. So I'm going to break this video now here and do this one in the next video, We haven't got much left, so we would be able to finish this in the next video. Alright, so I'll let you go, and when we come back we'll do question 14. Oh, sorry. There we go. See you later, and don't forget you can always catch me up on Skype. Very, very important. Once again, my Skype is OLUSOLA.AYOOLA2014. Okay, you can't see that. Skype. You don't need to video call, just text and I'll reply your text with answers. Bye bye.